So in this video, we're going to take a look at infinite geometric series, and you can see the little infinite sign in the formula. And what this is going to really do is talk about, again, the concept that we learned called convergent. Now, convergent really means that the series is collapsing or decaying, using the exponential terminology, down to adding eventually nothing. So let me explain what we mean there. If I start with 1 and my R value is a half, my next term will be a half. If I multiply this by a half, I would get a fourth. If I multiply that by a fourth, I would get a 16th. And if I just keep going, you can tell that the numbers are getting smaller. And in fact, they eventually, if I look at them as a decimal, they eventually get so small that they become trivial, right? If I just keep going here, they just keep getting smaller and smaller and smaller. And what that means is that eventually when we keep going down to here, we're actually going to get to 0, because we're actually going to eventually have 1 over infinity. And that's where the infinity is here. If I went to the infinity term, if I went to term number infinity, then in this case I would have 1 over infinity, and 1 over infinity is called 0. Now that's your first time maybe you've seen something called a limit, and you'll see limits more when you are in calculus and pre-calculus. You might have thought about an asymptote, specifically a horizontal asymptote, as a limit, possibly when you did rational functions. So this actually makes this formula the same as this formula right here, the one we've been using, 1 minus r to the n over 1 minus r. What happens is, as r, as we keep going, as n goes to infinity, then this part right here goes to 0, leaving us with 1 over r minus n times a1, which gives us this formula. So just remember that when you're looking at this formula, really looking at this one, we do this when we have a convergent r value that's between 0 and 1, meaning a fraction or decimal that's between 0 and 1. The absolute value is to take care of if you have a negative r value. Even if these alternated from positive to negative, they eventually would still have the same problem. So keep that in mind, that they would eventually do the same thing. The formula would evaluate a different number with a negative in it, but it still would be useful. Keep in mind there's a hidden parentheses around the numerator and denominator. And very important is keep in mind that r value has a parentheses as well, because all these r values are going to be fractions or decimals between 0 and 1. So that extra parentheses is super important. All right, so let's take a look at some problems that we've seen similar to ones that we've already done, but that have notable differences. So the first thing you'll hopefully notice in this problem is that we have a fraction. We're going to determine exactly what that is. We also have this dot, dot, dot right here, and that is meaning that it's going to go on to infinity, right? It's going to infinity, which is kind of a key way to know what we're looking at. So nothing else changes. We're still going to find our r value by doing a2 divided by a1, which in this case would be 9 over 12. Please take super care that you're not doing this the wrong way. It's always the second one divided by the first one, because if your fraction's upside down, you won't think it's convergent. So here we get 3/4, and 3/4 is, it meets this requirement that the absolute value of r is between 0 and 1. So this is a convergent r value, which is required, okay, to use the formula. And then once you know that, you just use this formula, but only if it goes to infinity. I mean, if it gave us a term over here, if it gave us something, we would have to use the Sn finite. It's only when you have a dot, dot, dot with a convergent that you would then use this special formula for convergent infinite series. So our a1 value is still 12, just like it was before. We now have 1 minus r, which is 3/4, and then we just evaluate this using arithmetic. So on the bottom, we would have this 1, you'd want to change that to 4 over 4, and so you would get 1/4, and then you would use keep, change, flip, otherwise known as reciprocate your denominator and multiply it times your numerator. And so this will come out to 48. Okay, so I went ahead and evaluated it, I guess, to show you how that formula works. But it did ask me to write, that in sigma notation. So I'll change the color on that to match that font. That was the second part there. So what we're going to do now is we can go ahead and evaluate the sigma notation. We have everything we need on our paper. So it did say rewrite the following using the series sigma notation. We have our first term, so n equals 1. We're going to infinity. Inside here, we always just write the formula for the sequence, right, which is easier for geometric. And it doesn't change this at all. This doesn't change when I have an infinity. So A1 would be 12, and R we found to be 3/4. We're still going to have our n minus 1, which is what we want, and we found that this comes out to 48. So no matter how many terms we add, if we go to infinity, if we add a billion terms, it's going to be approximately 48. But if we add infinity, it'll be exactly 48. All right, so now we're going to take a look at some that are already in this notation. And when you have one that's complete like this, you have the infinity. Again, we're looking at this thing now. We have a 1, right? We have R. We're pretty much good to go. In this case, we're just going to be using the formula S infinity is equal to A1 over 1 minus R. And it's just a simple exercise of plugging the correct numbers in the right spots at this point. Please keep in mind to put that in a parentheses, and just remember that when we evaluate this, all you really have to do is just make this 1 become a number out of the correct denominator. 5 over 5 is 1. It matches that denominator. So now we end up with 2 divided by 1/5. And if you keep change flip or reciprocate your denominator, however you were taught to do that, this would come out to 2 times 5 over 1. So this will come out to 10, meaning this thing is equal to exactly 10 with the infinity sign on it. So then we come to our second problem, which is a problem. It's actually exactly the same. You go back and look at the video we did here. It's exactly the same as this problem, but this one was to 12. And remember when we had this problem, we had to rewrite it because we didn't know the correct first term. In both formulas, both the infinity and the finite have an A1 in them. So we have the same problem here. What we have is that we have a problem that goes to infinity, okay? But the problem is that this A1 can't be correct. And the reason it can't be correct is because we have a problematic exponent and we have a problematic start point. So the reason that this isn't such an important thing to look at is when I think about this formula, S infinity is equal to A1 over 1 minus R. The A1 is talking about an A1 that starts at 1 and has the correct exponent, which I do not have. So I'm going to do a little iteration here. I'm going to find A1, A2, and A3 using this formula. You may, of course, use a calculator if you need to. So what we'll do is we'll type in 6, and then 1/3, and then we'll raise that to, and if you want to, you can actually raise it to the 1 plus 2, so you can see exactly what you're getting. Just make sure see, right now it's not an exponent. Make sure you make it an exponent. And so that comes out to 2/9, just like the previous one we had. And the nice thing about something like Desmos is you could just copy that and then just hit enter and do the next one and do the next one and just change it from 1. We're going to look at term 2 and term 3 and just toggle them. So those are your 3 terms. So 2/9, 2/27, and 2/81. And here's the thing, you don't have to write out 3. I just find that students understand it better if they have 3 terms rather than just 2. You really only need to find A1. And the reason is that I'm still multiplying, right, by 1/3 to get to the next term. And so the whole reason I make students write out 3 terms is so they can see what's happening. All you really need to do is just rewrite this formula. If you do this enough, you realize that all you really need to do is find A1, right? You just really need to rewrite A1 and the exponent. So this equation that we had up here is really n equals 1 to infinity. A1 was supposed to be 2/9 if I use the correct n minus 1 exponent, but R doesn't change. So to prove that to you, look, this is what we just had. I'm going to type in the new formula, which is 2/9 to the, oopsie, be careful with how you type. So click and then type in 1/3. and then raise that to the n minus 1. So if I want to do 1 there, I'd have 1 minus 1, right? So 1 minus 1, making that an exponent. And look, I get 2/9 again. And I can just take that again, and I can just, iterate it 2 more times for you. Term 2 would be 2/27. And term, sometimes you got to be careful how you write the stuff in here. So 2, and then I'll put a 3 there. There we go. So you can see that I'm producing the exact same terms. I'm just producing them with a equation that can actually be put into the formula. So now that I've rewritten with the correct A1, to find the summation to infinity, it would be 2/9, the correct A1, not the wrong A1, divided by 1 minus 1/3. Same deal here. This always happens because you're subtracting from 1, so we just change this to the correct fraction with the correct denominator to match the R value. And so we would get 2/9 divided by 3/3 minus 1/3 is 2/3. And then if you keep change flip, you can figure that out. Keep change flip or multiply by the reciprocal. So 2/9 times 3/2 comes out to 3/9, which is 1/3. And of course, you could have used a calculator for that, but it's not a bad idea to use your arithmetic. So this original problem is equal to 1/3. I just can't use the formula. And then this problem right here is also equal to 1/3. So this sort of throws students off, but you have to understand the formula requires the correct A1 balanced with the correct exponent and starting place, and that's why we have to rewrite it and figure out the right equation. All right, let's look at one that has to do with given information, finding whatever term they particularly ask for. And so this last one, again, we are kind of taught right here that, hey, this is an infinity problem. So we know what we're looking at. So as soon as you see that, your brain just needs to shift, right? It needs to shift to thinking about this formula. I see that, I write, oh, S infinity is equal to A1 over 1 minus R. And then I just see what I have. Well, S infinity is given, it's 12, meaning they did a problem like I did here, and I got 10 for this thing, and they got 12. A1 is what I'm looking for, right? So A1 in this problem is the actual question. Find A1. And then I'm going to divide that by 1 minus R, which they gave me is 1/3 right there. So same old trick here. I'm going to change this into 3/3. All right, so I get 12 is equal to A1 over 3/3 minus 1/3, which is 2/3. And a lot of students will get confused by this, and there's 2 ways you can do it, right? The first way you can do it is to just simply multiply by that on both sides, multiply 2/3 on both sides. The other way to do it, if that's confusing, is to keep change flip this, right? That's fine if you want, and so that would give you 12 is equal to A1 times 3/2, and that's fine, right? But then you would have to multiply by the reciprocal, which would be 2/3. So probably the best thing to do when you see a fraction, right, is to always just remember whatever the denominator is, 2/3, x, 17, just multiply by that denominator and it will always cancel. Just make sure you do the same thing over here. All right, and so evidently when you do this, A1 would be 2 times 12 is 24. 24 divided by 3 is 8. So evidently, it's not so bad to do. You just have to make sure you're following the right equation based on whether it says infinity or not. Now, keep in mind that problem, if I went back and looked here, it's actually almost exactly the same as this one. The difference is here I have an 8. 8 is a finite number, so I used S of n. Here, it said infinity, so I used the infinity formula. And then you just follow the solving techniques from there. But make sure you simplify before you try to solve. This is where I solved. This was just simplifying the denominator. Just don't forget about that parentheses, right, that we have here and here. That's what will help you get to this answer.